Now that we've calculated the coefficients for B, we can go on to calculate all of the regression results for multiple regression. The first step in calculating all of the regression results will be to calculate the values of y hat, which we will put here. Now, an easy way to calculate y hat is to simply multiply the original X matrix times the B matrix. So we will do that. First we will highlight 10 cells, and you can see that I have highlighted 10 cells here. And in the first cell we will type equal M mult and a left paren, and now we'll select the X matrix and a comma, and then we'll select the values of B and hold down Control Shift and hit Enter, and we now have the predicted values for Y, the values which we would predict on the basis of these B coefficients. The next step in calculating the regression results is to find y minus y bar. Y minus y bar will be the actual value of y minus its mean. This can be found by typing in equal the first value of y minus average of all of the y's, and we'll fix these with an F4, so we will always be using the same set of numbers, and then enter, and this is the first difference value, and if I copy this all the way down, these are all of the values of y minus y bar. Next we'll calculate the values of y hat, the predicted values of y minus y bar. So this will be y hat minus y bar. It's the same process, equal y hat minus the average of y, and again F4, and when I hit enter I get the difference between the predicted value of y and the average of all the y's. When I click this down, I now have all the values of y minus y bar. Now we need the difference between y and y hat. So this will be y minus y hat, and that will be equal to the actual value of y minus the predicted value of y. And this can be copied down to each of the remaining cells. We now have y minus y bar, y hat minus y bar, and y minus y hat. These are all the values we need for the sums of squares due to regression, the sums of squares error, and the sums of squares total. Here we'll put the sums of squares. This will be total. This will be regression, and this will be error. The sums of squares total is equal to sum SQ of y minus y bar. The sums of squares due to regression is equal to y hat minus y bar rather the sums of the squares of y hat minus y bar. And finally, the sums of squares due to error is equal to the sum of the squares of y minus y hat. Here we'll put the degrees of freedom. There are 10 observations, so the total degrees of freedom are 10 minus 1, or 9. There are 2 regression coefficients, so the degrees of freedom for regression are 2, and the error degrees of freedom are equal to the total degrees of freedom minus the degrees of freedom due to regression. So this is equal to degrees of freedom, total degrees of freedom minus the degrees of freedom used in regression. Now we can calculate the mean square for regression and error. This is equal to the regression sums of squares divided by the degrees of freedom. And when I drag this down, I get the error mean square. Now we'll move to the right for the rest of the calculations. Here we have the f, and we have the probability of f. The f is equal to the mean square due to regression divided by the mean square error. And the probability of that f is equal to f dist, the value of f, comma, degrees of freedom in the numerator, comma, degrees of freedom in the denominator. We now have the probability of the f, which tells us that at least one of the 2 variables, size and visibility, is a statistically significant predictor of cost.